This is Module 5, Lesson 15. In this lesson, we'll be finding common units or numbers of units to compare to fractions. Let's start with the fractions 3/4 and 4/5. And let's think about the strategies we've used so far to compare fractions. The first one we looked at was using benchmark fractions. 3/4 is greater than 1/2 and less than 1. 4/5 is also greater than 1/2 and less than 1. So benchmarks don't really help us. The other thing that we have tried for comparison is using like units. And in these two fractions, the numerators are different and the denominators are different. We also looked at a strategy of finding one either numerator or denominator that was a factor of the other one, but 3 is not a factor of 4, and 4 is not a factor of 3, and 4 is not a factor of 5, or 5 a factor of 4. So given the strategies we looked at so far, we can't apply any of them to these two fractions. But there is a strategy that always works, and that is to take the two denominators, in this case 4 and 5, and multiply them together to get a product, which is 20. So if we decompose each of these fractions separately into an equivalent fraction with a denominator of 20, then it's easy to compare them. And since we've multiplied 4 times 5, then we know that both 4 and 5 have to be factors of 20. So in order to get 20 for this fraction, we're going to multiply by 5. So we're decomposing the denominator by 5, and we're decomposing the numerator 5 times. And if we multiply, we get 15/20. And here, in order to get 20ths, we're going to multiply the denominator by 4. So we're decomposing 4 times. And if we're decomposing the denominator, we need to decompose the numerator by the same factor, and we get 16/20. So now comparing these two fractions is easy. The units are the same. 15 is less than 16. Therefore, our original fractions, 3/4 has to be less than 4/5. And this will always work. If these two strategies don't help you, multiplying the denominators to get a new denominator that is a product of the two will always work. Let's see what this looks like in area models. So let's start with our first fraction, which was 3/4. And if we shade 3/4, that would be the first one. And in order to get 20ths, we need to divide this again into 5 equal-sized pieces. And now if we count, we see we have 20ths. And if we count the shaded units, we see we have 15. Then if we look at the second fraction, it's originally 4/5. So we start with 4/5. And in order to get 20ths, we're going to need to divide this 4 more times. And so we end up with 20/20ths as our unit. And if we count, 16 of them are shaded. So when we do our decomposing, as we've seen up here, these are the two area models that prove that, in fact, these fractions are equivalent. Therefore, when we look at 15/20ths and 16/20ths, 15/20ths is less than 16. So if 15/20ths is less than 16/20ths, then we know 3/4 is less than 4/5, since the fractions are equivalent. Let's look at another one. Let's look at two fractions that are greater than 1. Okay, again, benchmarks don't really help us. None of the units are the same here. None of the units are factors of each other the way they are right now. But let's decompose this into the whole number plus the fractional part. And since these both equal 1 and those are equal, all we really have to do is compare the two fractions. So if we have 2/3 and 3/4, and we multiply the denominators, we get 12. So we're going to decompose 2/3 into 12ths. So to get 12ths, we're going to need to decompose both the numerator and the denominator by 4, and we get 8/12ths. If we do the same thing with the other fraction, and we want to end up also with 12ths, we're going to need to multiply by 3 to decompose into 9/12ths. And then we easily see that 8/12ths is less than 9/12ths. Therefore, 2/3 is less than 3/4. And if that's true, then 5/3 is also less than 7/4. Let's look at another one. Let's look at 3/5 and 8/12. Again, benchmarks don't help us. None of these units are the same already. None are factors of each other. So we're going to use our new strategy of multiplying the denominators to get 60ths. We're going to decompose each fraction into 60ths. So we're going to need to multiply the denominator and the numerator by 12. And we get 36/60ths for 3/5. And if we start with 8/12ths, again, to get to 60ths, we're going to need to multiply by 5. And we get 40/60ths. And again, now it's very easy to compare since we have the same units. We're talking about 60ths. And we can see 36/60ths is less than 40/60ths. So since these fractions are equivalent, therefore 3/5 also has to be less than 8/12. So let's try some problems in our problem set. So for the first one, it says draw an area model for each pair of fractions and use it to compare the two fractions by writing greater than, less than, or equal to on the line. The first two have been partially done. And it also tells us that each rectangle represents 1. So in the first one, we see that 1/2 is already shown as being less than 2/3. And in our area model, we started with drawing halves, and we showed that, and that is represented here. And then to get to 6, then we had to divide again. So now we have 6. And so originally we had 1/2 shaded, and now we can say that it's equal to 3/6. So 1/2 is equal to 3/6. Down here, we started with thirds, and we started with 2/3. And then we divided again to get 6. And now we have 4/6. So 2/3 is equal to 4/6. And so we see that 3/6 would have to be less than 4/6. Therefore, 1/2 is less than 2/3. Okay, stop the video and try B. Okay, for B, we've got part of our area model drawn. So The first area model is 4/5, so let's shade that 4/5. And the second area model is 4ths. Let's shade the 3/4. So now we're going to find our denominator we're going to be using to create our new units. So we have 5 times 4 is 20. So now we're going to do 20ths. So in the first area model, I have 5ths. So I'm going to need to divide it into 4 more equal sized pieces to end up with 20ths. And if I count, I'll see that I have 16 20ths shaded. So 4/5 times 4 would be 16 20ths. In the second one, I started with 4ths, so I'm going to need to multiply by 5 to get 20ths. And I'd get 15 20ths. And on my area model, I started with 4, so I'm going to need to draw 5 equal sized pieces. And if I count, I see I have 15 shaded. So the area models show what I've done. So 16 20ths is greater than 15 20ths. Therefore, 4/5 is greater than 3/4. Okay, pause the video and try C. Okay, for C, we need to draw our own area model. So we're going to start with showing 3/5. And our second fraction is 4/7. And now to find our new denominator, we're going to multiply 5 times 7 and get 35. So our new units are 30/5. So if we start out with 3/5, we want to end up with 30/5. So we're going to need to multiply by 7. So on our area model, we're going to need to draw 7 equal size rows. And that would be 21 35ths, 3 times 7. In the second fraction, we have 4/7. And again, we want to end up with 35ths. So we would have to multiply by 5 to get 35ths. And we'd need to divide our area model into 5 equal size rows. And we see we have 20 shaded. 21 35ths is greater than 20 35ths. Therefore, 3/5 is greater than 4/7. Try D. Okay, once again, let's start with our area model for our original fraction. We have 7ths. 3/7 are selected as shown by our numerator. Second fraction is 2/6. So we'll shade our 2. Our new unit for our denominator will be 40 seconds. So we start with 3/7 and we want to end up with 40 seconds. So we're going to need to multiply by 6. So we'll get 18 40 seconds. In our area model, we're going to need to draw 6 equal size rows to show this. And if we count, we have 18 shaded units. For 2/6, again, we want to end up with 40 seconds. So we're going to multiply by 7. And we're going to divide our area model into 7 more equal size rows. And if we count, we see we have 14. 18 40-seconds is greater than 14 40-seconds. So 3/7 is greater than 2/6. Pause the video and try E. Okay, start again with our area models to show 7/8. I'm sorry, 5/8. And our second fraction is 6/9. And we'll shade 6 of them. Our new denominator will now be 72. So we're doing 70 seconds. So we start with 5/8. And we want to end up with 70 seconds. So we need to multiply by 9. So we'll get 45 70 seconds. And we need to now draw 9 rows. And for the second fraction, 6/9, we want to end up with 70 seconds here also. So we're going to multiply by 8. And we're going to draw 8 rows. And comparing our two fractions, 45 70-seconds and 48 70-seconds, 48 is going to be greater. Therefore, 5/8 is less than 6/9. Pause the video and try F. Here we start out with thirds. And 2 of them are selected as shown by the numerator. Second fraction is 3/4. And 3 are selected. Our new denominator is going to be 12. So our units are twelfths. So 2/3 would be multiplied by decomposed 4 times to get 8/12. And we need to add 4 rows to our area model. And if we count, we see we have 8/12. For the second one, we have 3/4. And we also want to end up with 12, so we're going to multiply by 3. And we get 9/12. And we're going to draw 3 rows. And we count, we see we have 9 shaded. Comparing 8/12 and 9/12, 9/12 is greater. Therefore, 2/3 is less than 3/4. Okay, for number 2, it says rename the fractions as needed using multiplication in order to compare each pair of fractions by greater than, less than, or equal to. So for this one, we're not drawing the area model, though if it does help you, you're welcome to do that. Pause the video and try A. Okay, for this one, our new denominator is going to be 30, the product of the two denominators. So for 3/5, we want to end up with 30ths. So we're going to multiply by 6 and get 18/30ths. For 5/6, also 30ths, we're going to multiply by 5. And we get 25/30ths. 18/30ths is less than 25/30ths, so 3/5 is less than 5/6. Whoops, I did it backwards. 3/5 is less than 5/6. Okay, try B. Okay, for B, our new denominator would be 48. So 2/6, we'd multiply by 8 and get 16/48. And for 3/8, we'd multiply by 6 and get 18/48. And 16/48 is less than 18/48. So 2/6 is less than 3/8. Try C. Okay, here our new denominator would be 40. So 7/5 times 8 would give us 40ths, would be 56 40ths. And for 10/8, to get us 40th, we'd multiply by 5, and we get 50 40ths. 56 40ths is greater than 56 40ths is greater than 50 40ths, so 7/5 is greater than 10/8. And try D. Okay, here our new denominator would be 15. So 4/3, we'd multiply by 5 and get 20/15. And 6/5, we'd multiply by 6. I'm sorry, we'd multiply by 3. And we'd get 18/15. 20/15 is greater than 18/15, so 4/3 is greater than 6/5. For C, it says you can use any method you want to compare the fractions and then record your answers using greater than, less than, or equal to. So pause the video and try A. For A, I go back to a prior method that we've used because 4 is a factor of 8. So that would mean I only need to change the fourths into eighths. And I get 6/8. This fraction is already in eighths. So 6/8 is less than 7/8. So 3/4 is less than 7/8. Try B. For B, I see that 6 is a factor, 3 is a factor of 6. So again, I only need to change one fraction to make the numerators the same. And I get 6/10. So if I'm comparing 6/8 to 6/10, tenths are smaller pieces than eighths. So 6/8 is greater than 6/10. Pause the video and try C. For C, none of the numerators are not multiples of each other, one of the numerators is not a factor of the other one. Same with the denominators. So I'm going to go to my new strategy of multiplying the denominators and getting 24. So 6/4. To get to 24ths, I'm going to multiply by 6. And I'm going to get 36 24ths. And for 8/6, I'm going to multiply by 4 and get 32 24ths. And since 36 24ths is greater than 32 24ths, 6/4 is greater than 8/6. Pause the video and try D. For D, again, I don't see any other easier way to do it, so I'm going to multiply the two denominators together to get myself a new common denominator. So 8/5, I'm going to multiply by 6 and get 48 30ths. And 9/6, I'm going to multiply by 5 and get 45 30ths. And 48 30ths is greater than 45 30ths. So 8/5 is greater than 9/6. So pause the video and try number 4. Okay, there's many different answers to this one. One way is to use benchmark fractions. Such as 1/2, 1, 1 1/2. Another one is to look for common units. Such as same denominator, or same numerator. I could just give an example. So these have same numerators. And thirds are greater than sixths. And another thing I could do is I could construct common units. By multiplying. For example, 2/3 and 3/4. 3 times 4 is 12. So my new denominator is 12. My new units are 12ths. So 2/3 times 4 gives me 8/12, and 3/4 times 3 gives me 9/12. 8/12 is less than 9/12. So 2/3 is less than 3/4. And that's the end of lesson 15.